6 centuries ago, someone wrote a book. Not a diary. Not a prayer. Not a story meant to entertain. It was something stranger. Something that feels like it was never meant to be understood. It wasn't written in Latin. It wasn't written in Greek. It wasn't written in any known language on earth. The letters curve and twist in unfamiliar ways. They repeat in patterns that look deliberate. And yet, no scholar recognizes them. The pages reveal impossible plants. Leaves that resemble nothing in biology. Roots that twist into abstract geometries. Constellations that match no known sky. Human figures floating through unknown systems. It looks scientific, but it feels alien. For 600 years, the brightest minds tried to read it. Medieval monks examined it. Renaissance scholars analyzed it. Linguists mapped its symbols. Cryptographers attacked it like a battlefield. Every generation believed it would be the one to solve it. Every generation failed. During World War II, elite codebreakers studied it. These were the same minds who cracked military ciphers. They dismantled enemy encryption systems. They decoded secrets that changed history. But this manuscript resisted them. It offered patterns without meaning. Then came the age of machines. Computers that simulate galaxies. Systems that model climate collapse. Algorithms that predict protein structures. Machines that defeat chess grandmasters. Surely, this medieval puzzle would fall quickly. But the supercomputers stalled. Algorithms scanned every letter. They calculated frequency distributions. They measured entropy levels. They searched for statistical fingerprints. And still, nothing coherent emerged. The manuscript behaves like real language. Words repeat consistently. Sentences follow structural rules. Patterns remain stable across hundreds of pages. It does not look random. It looks intentional. But no known language matches it. Not Latin. Not Hebrew. Not Arabic. Not any European dialect. Not any recorded extinct tongue. The comparison always returns the same result, no match. So how can a medieval book defeat machines that model the universe? How can ink on parchment outthink silicon processors? How can patterns exist without translation? What are we missing? And what does this failure reveal about intelligence itself? Before decoding the text, scientists asked a simpler question. Is it real? Could this entire manuscript be a forgery? Could someone have created an elaborate hoax? The first step was to test the material itself. And science began with the parchment. Researchers performed radiocarbon dating. Tiny samples were extracted from the calfskin. The results were precise. The parchment dated back to the early 15th century, around 1404 to 1438. The book was undeniably medieval. Then they tested the ink. Was it added centuries later? Was the text written on old blank parchment? Chemical analysis revealed consistency. The ink matched the period. There was no modern contamination. The writing was authentic to its time. The pigments in the illustrations were examined next. Mineral compounds were identified. The colors matched medieval sources. No synthetic dyes. No industrial chemicals. Every material pointed to the 1400s. The binding was analyzed as well. The stitching style matched early Renaissance techniques. The thread fibers were period accurate. The wear patterns showed natural aging. Nothing suggested fabrication. This was not a modern trick. Historical records traced its ownership. It appeared in the court of Emperor Rudolph II. Scholars believed he paid a fortune for it. Even in the 16th century, it was already mysterious. Its origins were unknown even then. Letters attached to the manuscript provided clues. One referenced the English scholar Roger Bacon. Some believed he wrote it. Others disagreed. The theory collapsed under modern dating. But the mystery deepened. By the 20th century, it surfaced again. A rare book dealer acquired it. His name was Wilfrid Voynich. And from that moment, the manuscript carried his name. The mystery entered the modern world. Universities began scanning it in high resolution. Digital archives preserved every page. The manuscript moved from vaults to servers. From secrecy to global access. Now, anyone could study it. But access did not mean understanding. The science was clear. The materials were authentic. The age was confirmed. The history was documented. This was not a forgery. Which meant the real mystery remained. What was the author trying to say? Now the real decoding began. Researchers treated the manuscript like a cryptographic battlefield. Every symbol became a data point. Every word became a statistical pattern. The mystery shifted from history to mathematics. The fight moved into algorithms. The first test was frequency analysis. In real languages, certain letters appear more often. In English, for example, E dominates. These frequency fingerprints rarely lie. They reveal structure beneath chaos. So researchers measured every symbol. The results were surprising. The symbol distribution looked natural. Not random noise. Not evenly spread. It mirrored real linguistic behavior. The manuscript behaved like language. Next came word repetition analysis. Real languages repeat common words frequently. Words like the, and, or of. The manuscript showed repeating clusters. Entire sequences appeared consistently. This suggested grammar. Then researchers measured entropy. Entropy quantifies unpredictability. Random gibberish scores high. Structured language falls within a specific range. The manuscript's entropy was nearly perfect. Too structured to be nonsense. If it wasn't random, then it followed rules. But what rules? Substitution cipher? Simple letter swap? Analysts tested classic cryptographic methods. Caesar shifts. Monoalphabetic substitutions. Nothing worked. So they escalated. Polyalphabetic ciphers were tested. Multi-layer encryption models were simulated. Algorithms scrambled and unscrambled sequences. Patterns were extracted and compared. The results remained empty. Linguists joined the effort. Could it be a lost Romance dialect? A compressed Latin shorthand? An extinct Central European language? Statistical comparison engines searched across databases. No linguistic match emerged. Machine learning models were trained on it. Neural networks analyzed thousands of sequences. The system attempted to predict the next symbol. In real language, prediction accuracy increases quickly. Here, prediction stayed unstable. That instability was alarming. It meant the structure was real, but unfamiliar. The manuscript wasn't noise. It wasn't standard encryption. It occupied a strange middle ground. And that confused the machines. Classical cryptography had failed. Statistical linguistics had stalled. So researchers turned to modern artificial intelligence. Not rule-based systems, but self-learning neural networks. Systems designed to find patterns humans cannot see. The manuscript entered the age of deep learning. Neural networks learn through exposure. They analyze massive datasets. They detect subtle correlations. They build probability maps of language. Over time, predictions sharpen. Meaning begins to emerge from chaos. Researchers trained models on hundreds of languages. Living languages. Dead languages. Rare dialects. Even reconstructed proto-languages. The goal was simple. Find a statistical cousin. But the system found no close relatives. No shared grammatical skeleton. No matching morphology. The manuscript remained isolated. Like an island with no bridge. Statistically structured, but alone. Then came transformer models. The same architecture behind modern language AI. These systems analyze context across long sequences. They understand relationships between distant words. They predict meaning with remarkable accuracy. They seem perfect for the task. The manuscript was fed into attention networks. Every symbol compared to every other symbol. Context windows expanded. Relationships were mapped. Hidden dependencies were extracted. The machine searched for coherence. For a moment, patterns intensified. The model detected clusters. It identified recurring structures. Prediction accuracy rose slightly. Researchers felt cautious optimism. The numbers looked promising. But progress plateaued. Accuracy stopped improving. Context expansion produced noise. The patterns refused to align with known semantics. The model was predicting structure, but not meaning. Something fundamental was missing. AI excels at interpolation. It connects known data points. It thrives on context. But the manuscript offers none. No parallel texts. No bilingual anchor. No Rosetta Stone. The system was powerful. But it was blind. It could measure patterns. It could map relationships. But it could not assign meaning. And without meaning, intelligence stalls. Then, in 2018, everything seemed to change. A group of AI researchers announced a breakthrough. They claimed the manuscript had been decoded. Headlines spread rapidly. The mystery, they said, was finally solved. For a moment, the impossible felt possible. The team proposed a bold theory. The text, they argued, was encoded Hebrew. Vowels had been removed. Letters rearranged through algorithmic anagrams. The AI reconstructed possible meanings. It appeared coherent at first glance. The system produced translations. Short phrases emerged. References to plants. Mentions of people. Descriptions that seemed plausible. It looked like hidden knowledge had surfaced. Media outlets amplified the claim. Articles circulated globally. Social networks buzzed with excitement. After centuries of silence, the manuscript had spoken. Or so it seemed. The world leaned forward. But scholars were skeptical. Linguists examined the methodology. Cryptographers rechecked the algorithm. Historians reviewed the linguistic assumptions. Questions began to surface. The foundation looked fragile. The translation could not be reproduced. Independent teams ran the same algorithm. The results varied wildly. Words shifted unpredictably. Meaning dissolved under scrutiny. Consistency was missing. The grammar did not hold. The proposed Hebrew structure collapsed. The word boundaries were arbitrary. The anagram rules were flexible. Too flexible. The solution began to unravel. Critics argued the AI force patterns where none existed. When parameters are loose, meaning can be manufactured. The system was not decoding. It was guessing. Statistical illusion replaced true translation. Within months, confidence faded. The breakthrough claim lost credibility. Academic consensus rejected the findings. The manuscript returned to silence. Another attempt had failed. The world had hoped for closure. Instead, it received uncertainty. The most advanced AI systems had stumbled. Not because they were weak, but because something deeper was missing. The crisis was no longer about translation. It was about understanding intelligence itself. The failure revealed something unexpected. The problem wasn't computing power. It wasn't data storage. It wasn't processing speed. It was context. And context is everything. Artificial intelligence learns by comparison. It studies patterns across massive datasets. It builds relationships between known examples. It predicts based on probability. It thrives on shared structure. Remove that structure, and prediction weakens. The Voynich text exists in isolation. There is no bilingual key. No parallel translation. No external references. No cultural anchor. It floats alone in history. Compare that to the Rosetta Stone. A single bilingual inscription unlocked Egyptian hieroglyphs. Context made translation possible. Shared meaning bridged civilizations. Without that bridge, symbols remain silent. AI models depend on massive corpora. Billions of sentences. Trillions of words. Patterns layered upon patterns. The manuscript offers only itself. A single, closed system. That isolation confuses the machine. Imagine trying to decode dolphin language. But you only have one recording. No translation. No repeated experiments. No cultural context. Just sound. The problem isn't intelligence. It's missing perspective. The manuscript may represent a constructed language. Or a private cipher. Or a lost dialect spoken by a vanished community. If so, its ecosystem is gone. Language without ecosystem becomes undecipherable. AI excels at interpolation. It fills gaps between known points. It predicts what comes next. But true novelty is different. True novelty has no reference. And without reference, prediction collapses. The manuscript sits in that unknown zone. Structured, yet unanchored. Ordered, yet untranslatable. It behaves like language. But it connects to nothing we understand. That paradox defeats algorithms. And so the mystery deepens. The failure is not technological weakness. It is epistemological limitation. Intelligence requires shared meaning. And shared meaning requires context. Without context, even the most powerful machines fall silent. If AI cannot decode it, perhaps we are asking the wrong question. What if the manuscript was never meant to be decoded? What if it was designed to resist interpretation? Some scholars argue it may be an elaborate hoax, a brilliant illusion crafted to deceive. The hoax theory suggests the text may be meaningless. Random symbols arranged to mimic language, complex enough to appear authentic, but empty underneath. A puzzle with no solution. Yet this theory faces a problem. Statistical analysis shows internal consistency. Word frequencies follow Zipf's law. Patterns repeat with linguistic discipline. Randomness rarely behaves this way. Another possibility, a constructed language. A system intentionally designed from scratch. Grammatically consistent, yet entirely original. Like Esperanto centuries before its time. A private intellectual experiment. Constructed languages require structure. They require rules. And they usually require purpose. Communication. Philosophy. Identity. If this was constructed, for whom was it written? Some researchers suggest multi-layer encryption. A cipher beneath a cipher. Symbols masking phonetics. Phonetics masking meaning. A recursive security system centuries ahead of its time. During the Renaissance, cryptography flourished. Courts used coded letters to protect secrets. Diplomacy depended on encryption. Knowledge was power. And power demanded concealment. Figures like Leon Battista Alberti pioneered polyalphabetic ciphers. Complex systems designed to defeat frequency analysis. Encryption was becoming sophisticated. And intellectual elites were experimenting boldly. What if the manuscript represents a lost branch of that cryptographic evolution? An experimental cipher never documented elsewhere. A private project by an unknown genius. A message locked away by design. And then there is the most provocative theory. What if the manuscript encodes scientific knowledge? Botanical, astronomical, or medical insights centuries ahead of its era. Knowledge hidden to protect it. Or to control it. The manuscript's plants are unlike any known species. Leaves twist into impossible angles. Flowers bloom in geometric perfection. Roots form intricate spirals. They resemble art more than biology. And yet, they are drawn with scientific precision. Some appear medicinal. Others seem purely decorative. Scholars debate their function. Were they copied from observation? Or imagined? Every illustration challenges our understanding of medieval botany. Astronomical diagrams fill other sections. Circular charts, strange constellations, planetary symbols. Stars align in patterns unknown to modern catalogs. Some figures float within the sky like diagrams of motion. The cosmos appears simultaneously real and alien. Some images depict bathing women, pools of water, intricate plumbing, or allegorical systems. Are these medical illustrations? Ritual depictions? Or symbolic representations? Their purpose remains speculative. The illustrations are consistent with each other. Style, line thickness, pigment choice, all uniform. A single hand likely created them. This suggests planning, method, and intent. Someone invested decades. Some researchers believe the manuscript encodes scientific knowledge. Could it be alchemy, early herbal medicine, or forgotten astronomy? Perhaps it represents experiments lost to time. Its precision is undeniable. The manuscript may reflect Renaissance curiosity before it existed. A blend of observation, imagination, and theory. Artists and scientists were not separated then. Knowledge was both artistic and empirical. Its medical diagrams may suggest protophysiology. Organs, veins, and bathing systems appear in abstract forms. Some scholars see herbal remedies encoded in symbols. Others see ritualistic representation. Every page is layered with ambiguity. Even the star charts contain patterns unseen in Europe. Some researchers argue the knowledge might have originated elsewhere. Perhaps Islamic astronomy? Or Central Asian tradition? Or entirely fabricated? Every illustration deepens the mystery. They are scientific and artistic. Precise yet alien. Intended to communicate, yet indecipherable. The manuscript refuses to surrender its secrets. The manuscript's text exhibits patterns like a natural language. Repeated sequences. Balanced word lengths. Non-random distributions. Linguists confirmed it follows Zipf's law. These statistics are highly unusual for a hoax. Entropy analysis confirms this. Low entropy indicates structure. High entropy indicates randomness. The manuscript strikes a delicate balance. Enough structure to suggest meaning, yet unpredictable enough to resist translation. Repetition patterns suggest grammar. Certain glyphs cluster consistently. Others appear only in specific positions. Word boundaries are surprisingly uniform. This points to deliberate design. But linguistic comparison yields no match. Every known language fails to correlate. Classical ciphers fail too. Even polyalphabetic systems produce only noise. The manuscript resists all conventional analysis. Some sequences are palindromic. Others follow Fibonacci-like patterns. Statistical anomalies appear throughout. Could these be intentional? Or coincidence? The manuscript may encode information in multiple layers. Researchers use entropy maps to identify structure. Some sections appear more ordered than others. Others seem chaotic. The distribution is not random. The manuscript exhibits sections of controlled complexity. Could these patterns conceal language, mathematics, or code? Each hypothesis is plausible. Yet none have been verified. Every approach generates partial results. Frustration and wonder coexist. AI has advanced enormously. It can predict words and decode complex ciphers. It can simulate human reasoning. Yet the manuscript remains opaque. No algorithm fully cracks it. Its secrecy is enduring. Some suggest the manuscript is deliberately obfuscated. Multi-layer ciphers, private language, or coded knowledge. Every page may hide several layers simultaneously. Even reading one layer is difficult. Decoding is an intricate puzzle. Statistical analysis proves it is not random. Structural patterns exist. But meaning remains elusive. We can measure structure, yet understanding escapes us. The Voynich manuscript remains a frontier of human and machine intelligence alike. The manuscript may reflect knowledge from a forgotten civilization. A people who observed nature closely. Who understood astronomy, botany, and medicine in ways lost to history. Perhaps their wisdom was too advanced for the time. Or too secretive. Could it be a fusion of cultures? European, Middle Eastern, Asian influences blended. Knowledge transmitted through trade, travel, or migration. Ideas synthesized into a unique system. The manuscript may encode that fusion. Its botanical drawings could reflect real exotic plants. Perhaps observed in distant lands. Imported seeds, travelers' journals, or lost expeditions. Nature documented but not recognized by modern science. Astronomical diagrams may encode observations unseen in Europe. Stars, planets, constellations mapped uniquely. A record of knowledge lost to later generations. Could it reflect medieval attempts at universal understanding? Some suggest a secret society commissioned the manuscript. Guardians of knowledge. Protectors of forbidden science. Designed to encode information only the initiated could read. Concealment as power. Perhaps it was a teaching tool. A complex exercise in observation, reasoning, and memory. Only those trained could extract meaning. A proto-academic experiment. Or an initiation rite for scholars. Some even speculate extraterrestrial inspiration. An idea too radical for the time. Knowledge seemingly beyond contemporary science. Unverifiable, yet intriguing. Mystery persists across centuries. The manuscript combines art, science, and encryption. Its purpose may be scientific, spiritual, or symbolic. Or all three simultaneously. It defies categorization. Every page deepens the enigma. Its creator remains unknown. Perhaps a polymath, a secretive scholar, or a group of collaborators. A visionary who documented knowledge beyond their time. Or someone who simply wished to baffle posterity. And so, the Voynich manuscript remains a puzzle. Centuries of curiosity, thousands of hours of study, and the most advanced technology have yielded only partial insight. Its secrets are tantalizing. Its mystery endures. The line between knowledge and enigma remains blurred. In recent years, AI has returned to the challenge. Machine learning models have grown more sophisticated. Neural networks with billions of parameters analyze the text. Human researchers guide the models, interpreting outputs. Collaboration between human intuition and machine computation is key. Some models suggest plausible word patterns. Others highlight statistical anomalies. Each approach offers fragments of insight. Alone, they are incomplete. Together, they begin to outline the manuscript's structure. Human experts provide context. Linguists test hypotheses. Historians verify historical consistency. Botanists compare plant illustrations. Astronomers match celestial diagrams. Interdisciplinary collaboration enhances understanding. AI identifies patterns invisible to the human eye. Repeating sequences, probable grammar, statistical structures. Humans interpret meaning. Machines suggest correlations. Together, they form a tentative map of the unknown. The process is iterative. AI proposes possibilities. Humans refine them. Models adjust weights. Feedback loops enhance prediction accuracy. Slowly, understanding emerges from chaos. This collaboration mirrors a conversation. Between centuries, between human and machine, between intuition and computation. Each influences the other. Knowledge evolves. Meaning slowly crystallizes. Despite progress, full translation remains elusive. Partial insights abound. Some phrases make sense. Others remain opaque. The manuscript teases comprehension without revealing all. Mystery persists. Yet each breakthrough teaches us more about intelligence itself. How humans understand context. How machines detect patterns. How knowledge is encoded and hidden. The manuscript is a mirror of cognition. It challenges the limits of reasoning. The quest continues. Scholars, scientists, and AI collaborate. Each discovery is incremental. Every attempt refines our tools. Knowledge grows, even if full understanding remains beyond reach. The Voynich Manuscript reminds us that some mysteries endure. That knowledge can be hidden, encoded, or lost. Yet curiosity persists. Human ingenuity meets machine intelligence. Together, they chase the secrets of the past. As we step back, the Voynich Manuscript is more than a puzzle. It is a testament to human curiosity, to ingenuity across centuries, to the desire to encode and preserve knowledge. Every page whispers secrets we may never fully grasp. It teaches patience, observation, collaboration. Even when progress seems impossible. Sometimes the journey matters as much as the solution. The manuscript challenges our understanding of intelligence, human and artificial. It reminds us that context is essential. That knowledge is relational. That meaning is not always obvious. It invites imagination. Some see lost science. Others see art. Some see cryptography, others philosophy. Its ambiguity fuels exploration. Curiosity drives progress. Every attempt to decode, every AI model, every scholarly hypothesis adds value. Even failure teaches us something. The pursuit itself is knowledge. The manuscript is both teacher and enigma. Its secrecy reminds us that some knowledge is fragile. That preservation requires care. That innovation sometimes waits for the right mind and the right era. It challenges us to think beyond what we know. The manuscript bridges centuries. A dialogue between unknown hands and modern minds. Between medieval curiosity and contemporary science. Between human intuition and machine computation. Its lessons are timeless. We may never fully translate it. But every insight matters. Every question sparks further inquiry. Every attempt pushes the boundaries of knowledge. Mystery does not equal failure, it inspires. And in that pursuit lies the lesson for humanity. Curiosity, perseverance, collaboration, and wonder. Some mysteries endure, but they enrich our journey. The manuscript is a mirror of our quest for meaning. So, we leave the Voynich Manuscript partially unsolved. Its secrets still intact. But it invites one final question. What will you do when faced with a puzzle that defies understanding? Share your thoughts below.